Conditional types in TypeScript. This year, TypeScript gained a new feature that punches far above its weight. Working through our enormous backlog of unsorted TypeScript suggestions, and it's remarkable how many of them are solved by conditional types. Conditional types probably aren't something you'll write every day, but you maybe end up using them indirectly all the time. That's because they are great for plumbing or framework code, for dealing with API boundaries and other behind the scenes kind of stuff, like words. Note, this is a straightforward adaptation of 35-minute presentation giving at futurized London's TypeScript Night meetup, and therefore provides more context than an ordinary blog post might. I hope a lot of the context is interesting and useful even for seasoned TypeScript developers. If you prefer a no-frills experience, check out the TypeScript 2.8 release notes. Your first conditional type. Here's all plain JavaScript. Reading the code is clear to human that the dot to uppercase method call is safe. We can tell that whenever a string is passed into process, a string will be returned. But notice that we could also pass something like null into the function, in which case null will be returned. The calling dot to uppercase method on the result will be an error. Let's add basic type to this function so we can let TypeScript worry about whether we are using it safely or not. Seems sensible. What happens if we try to use it like before? TypeScript complains because it thinks that the result of process foo may be null, even though we clever humans know that it won't be. It can figure out the runtime semantics of the function on its own. One way of helping TS understand the function better is to use overloading. Overloading involves providing multiple type signatures for a single function and letting TypeScript figure out which one to use in any given context. Here we say that if we pass a string, it returns a string, and if we pass null, it returns null. The any type is ignored, but still needs to be there for some reason. That works nicely. But there is another use case that doesn't work. TypeScript won't let us pass something that is type of string or null, because it's not smart enough to collapse the overloaded signatures what that's possible. So we can either add yet another overloaded signature for the string or null case, or we can be like and switch to using conditional types. Here we introduce a type variable t for the text parameter. We can then use t as a part of the conditional return type. T extends string null. You probably notice that this looks just like a ternary expression. Indeed, it's doing the same kind of thing, but within the type system and compile time. And that takes care of all our use cases. So that's what a conditional type is, a kind of ternary expression, type expression. It always has this form. A, B, C, and D can be any old type expression, but all the important stuff is happening on the left there, in the A extends B condition. Assignability. This stem keyword is the heart of the conditional type. A extends B means precisely that, that any value of type A can safely be assigned to a variable of type B. In type system jargon, we can say that A is assignable to B. TypeScript decides which types are assignable to each other using an approach called structural typing. This kind of type system started appearing in mainstream language relatively recently, in the last 10 years or so, and maybe be a little counterintuitive if you come from a Java or C# background. You may have heard of duck typing in relation to the dynamically typed language. The phrase "duck typing" comes from proverb. If it looks like a duck, swings like a duck, and quacks like a duck, then it probably is a duck. In duck typing, you judge a thing by how it behaves, rather than what it is called or who its parents are. It's a kind of meritocracy. Structural typing is a way of applying the same idea to a static compile time type system. So TypeScript only cares about what types can do, not what they are called or where they exist in a type hierarchy. Take this simple example. TypeScript is happy treating two completely unrelated classes as equivalent because they have the same structure and the same capabilities. Meanwhile, when checking the types at runtime, we discover that they are actually not equivalent. This is a notable example of where the semantics of TypeScript are at odds with JavaScript. It may seem like a problem, but in practice, structural typing is a lot more flexible than JavaScript nominal typing, where names and hierarchy matter. The two aren't mutually exclusive, however. Some languages like Scala and Flow allow you to mix and match to suit particular problems. Aside from that, the way that assignability works with structural typing is very intuitive. Speaking structurally, we can say that A strings B. It's a lot like A is a superset of B, or to be more verbose, A has all of B properties and maybe some more. There is one minor caveat though, and that's with literal type in TypeScript you can use literal values of primitive types as types themselves. The string banana doesn't have more properties than any other string, but the type banana is still more specific than the type string. So another way to think of A extends B is like A is a possible more specific version of B, which brings us to top and bottom types, the least and most specific types respectively. In type theory, a top type is one which all other types are assignable to. It is the type you use to say, I have absolutely no information about what this value is. What this value is. I think of it as the union of all possible types. TypeScript has two types, any and unknown. Using any is like saying, I have no idea what this value looks like, so TypeScript, please assume I'm using it correctly and don't complain if anything it seems dangerous. Using oh no is like saying, I have no idea what this value looks like, so TypeScript, please make sure I check what it is capable and runtime of a runtime. A bottom type is one which no other types are assignable to, and that no value can be an instance of. Think of it, think of it as the empty union type.